cervical vertebrae. I just gave you the answer. Vertebral, yeah. So these are the two vertebral arteries, 1 and 2. And they come up and they fuse to become the basilar. You got it? Fuse to become the basilar. And then here, the basilar splits into, this is where we saw the fountain in that one picture. The two posterior cerebral arteries, here and here. Make sense?
Is that A? Is that the posterior on the angiogram? Can you tell? Not the down arrow, but the two up.
Oh, gotcha. That, since there's two, I would assume that's a vertebral artery, and then they fuse here to be the basilar.
Oh, I thought it was further down. Maybe I'm wrong.
I could be wrong.
It's hard to tell.
But since there's two there, that would make sense to me. Yeah, because it shows A is this and this down here. So that's got to be the vertebral arteries fusing together to make the basilar artery. Is everybody good with that picture? Okay. Okay, so the communicating arteries, which we kind of already touched on. We have they're short, narrow segments that complete the circle. We have the anterior communicating artery. Remember, we have one or two of those. One, you got it. And it connects the right and left anterior cerebral arteries. Remember, it was at the very top where the two long pieces of the anterior cerebral artery came up, and there was just a tiny little spot right there, and that's where the communicating artery is. And then posterior communicating artery, we have one or two. Two, exactly. And they connect, the middle cerebral artery back to the posterior cerebral artery. Oh yeah, see the way that it's shortened there, A, PC, A. That's how you can do it if you're going to shorten it, so you don't get it confused with the cerebral arteries, because these are communicating arteries. Okay. There's another picture of the circle Willis, just to bring it all back together. So you got these posterior communicating arteries connecting the middle cerebral artery and the posterior cerebral artery, 1 and 2, and the anterior communicating artery connecting the two anterior cerebral arteries. Everybody good with the circle of Willis? So this is a diagram that's showing the blood supply, and this is really good because you can see. So up here is the area supplied by the anterior cerebral artery, and this middle area is supplied by the middle cerebral artery, all around here, and the area supplied by the posterior cerebral artery is down along here. So does this make sense? This is the lateral portion. This is the medial portion, because it's coming back over to the center of where the two hemispheres meet. Lateral portion on the outside, and then posterior portion. And then this is, the brain's been cut straight in half. So you can see the anterior cerebral artery all along here, because that's the medial portion. And then the posterior cerebral artery. And then just this tiny bit you can see from the middle cerebral artery, right? Because it mainly supplies the lateral surface of the brain. That make sense? So as you can see, this is where the middle cerebral artery, their terminal branches kind of meet up with the anterior cerebral artery branches. So they kind of intermingle, they kind of cross over. And this area along here, that's called the watershed area. And that's important to know. You'll learn more about that when you take aphasia in grad school. So right along there. It's called watershed area. W-A-T-E-R-S-H-E, watershed. That's just where there's kind of intermingling of the terminal branches of ACA and MCA, and so there's, I guess, overlap of blood supply. All right, so now we're going to talk about stroke. Stroke is technically called a CVA. I don't know if you guys have heard of it called that before, but that's what they'll call it in hospitals. And it refers to a cerebrovascular accident. Can also be called a brain attack, although we don't really call it that, so I'm not really sure what it's there. I guess maybe that's the lay term for it. So basically a stroke is an interruption of blood flow to the brain that results in damage to brain tissues. That's kind of what we talked about at the beginning when there's an interruption of the blood flow to the brain and then there can be damage. And that's what a stroke is. So does anybody know what a TIA is?
A mini stroke.
Mini stroke, exactly. Transient ischemic attack is a mini stroke. And it's kind of your body's way of saying there's something going on and you need to get attention. But usually, mini strokes or TIAs, the symptoms last less than 24 hours, and usually the blood clot dissolves on its own. So that's a transient ischemic attack. Mini stroke.
They say sometimes you don't even know it.
Yeah, exactly. There are times that you may not even know that you had a TIA if you've had one. So sometimes they'll go in and have like an angiogram done or something like that, and they'll see that people have had TIAs that they didn't even know that they have had because they didn't have long enough symptoms that were long lasting and stuff. Okay, so we have two types of strokes. The first type is ischemic, which is an inadequate blood flow to the brain. And then the second type of stroke is a hemorrhagic, which means that there's a blood vessel that's burst, and it's often related to an aneurysm. Does anybody know what aneurysm is?
Like a blood.
Yeah, exactly. It's actually a weakening of the wall of the artery. So it kind of looks like, I don't have any, so you have the artery like this, and it kind of goes up and it looks like a balloon. So it's a weakening of that artery that comes out. So it looks abnormal. Does that make sense? Sorry, I don't have anything written. I think I'll show a picture later. Okay, so two types of stroke: ischemic, inadequate blood flow; hemorrhagic, which makes sense, blood vessel burst. Hemorrhagic means to bleed, right? So the blood vessel bursts, and it's often related to that aneurysm, which is the weakening of the wall bursting, causing the hemorrhagic stroke. So of the ischemic, when we're talking about ischemic strokes, there are two types. You have a thrombus, which is when the blood clot develops in the brain, and you have an embolus when it travels to the brain, often from the heart or somewhere else around the brain, and it travels to the brain. And then the fact that it's a blood clot is not the issue, it's the fact that the blood clot gets stuck in the artery and stops the blood flow from going out to the brain. So the hemorrhagic stroke is when the blood vessel bursts, and we have intracerebral hemorrhage, which is in the brain tissue itself. We have the subarachnoid hemorrhage, which is between the arachnid and the arachnid layer of the brain and the brain tissue. So it's essentially on the surface of the brain. And then finally, there's a subdural hemorrhage. duromotor and